Tim Coyle from Signal Bytes Technology, and welcome to the Week 5 update on my connected pool monitor. So let's go over what happened this week. So this week I really ended up doing a lot more market research than I did technical stuff, so I thought I'd talk to you guys about my business plan. So for the Week 4 update, leading up to that weekend, I was doing a lot of stuff with the probes and actually did the pH pool test, so hopefully you guys saw that video. And as you know, I'm entering my pool monitor into the Hackaday contest, which is part of their yearly contest that they do. It's one of these design entry contests, and you can win prizes, and it's just a fun way to kind of keep yourself motivated and share your project and some ideas with people in the community. So anyways, one of the things you had to do to enter the contest was to come up with a rough business plan. So I put together some slides. I had maybe 10 or 15 slides that I put together as kind of a rough pitch deck, and I have that post up on my website if you want to take a look at it. But I learned a couple of things when looking at the market research. And this is obviously something that you should do even before you try and build even a proof of concept for a product. But a couple of the main things I learned was that there's about 10, 11 million residential pools in the United States, and the split is actually about even 50%. It's a little less than that between above ground pools and in-ground pools, which I thought was pretty interesting. And then the other interesting thing was how the filtration systems broke down. So it was basically 30% between sand, salt, and some other ones. So that was interesting to look at the breakdown. So for me right now, my pool's an above ground pool with a sand filter, and that's really what I've been focusing my measurements on and some of my formulas. So obviously going forward, I'm going to have to adapt that to deal with salt water filtration systems as well, which I don't think would be a big deal, really in most of my calculations, but in terms of reliability and the probes dealing with the corrosiveness of salt, that might be an issue. But the other thing that I spent some more time on this week was looking at, some competition, what's out there for other, I'll call it Internet of Things, connected pool monitors, and there's a couple more well-known ones, I guess, that have gotten some funding, some that are actually shipping product. So that's been interesting to see what other people have been trying to do. And I'll talk about one key thing I took away that I didn't see a lot of other systems doing unless it was a commercial system, and that was actually running the pool filter pump. And I thought that was kind of interesting because there's a couple of devices out there, and there's been some out there for a while, where you can put the monitor in the pool and it'll at least tell you the temperature, it'll tell you the pH, and there's some that are trying to tell you when you need that chemicals, kind of like I'm doing. But none of those are really tied into the pool filter or running the pool filter or adding the chemicals automatically. And if you go and look at these commercial systems, you think like a hotel swimming pool or a residential complex swimming pool, something where there's lots of people using it, it's a big pool. If it's being managed and maintained, by a pool service company or a control style industrial company, that they've got these monitoring units and stuff, but one of the things they do is they control when the filter runs and when the chemicals are added. So it's really the next level. It's a lot more automated, and so when looking at one of the potential selling features of making this into a product would be the cost savings. So I realized that it's just not about saving on pool chemicals, but it's also on saving on electricity cost of running the pool filter pump. So, and also, if we're going to make a formula and we're going to have the data to tell us, okay, this is when you need to add chlorine and this is when you need to add sanitizer to your pool, then it makes sense to wrap up into that how the pool filter works, right? Because you need the pool filter to circulate the chemicals as well as do the filtering and keep the pool clean. So, you can balance the pH and the clarity of the water all you want, but if you don't ever run the pool filter, it's going to get dirty. So you can't ignore that fact. But like I said, I think looking at the cost of running the pool filter, the electricity cost of that would be interesting. And, it's certainly something we could do with this system with Arduino. We could add a relay essentially into, the AC plug of the pool filter, turn it on and turn it off and set a timer. Really alone, that could be a product. People buy remote timers all the time for different things. Turn on your hose or turn on a light, connect it through Wi-Fi. So it could be maybe something that can be embedded into this product. So that's something that I'm going to be looking at behind the scenes. And I think that could be a good feature. And the last thing in looking at the business plan was was sort of trying to continue on with the cost savings. One interesting formula I found from a spa and Aqua site was they said roughly that the maintenance cost a year in a pool are 10% of the installation cost. Now, if you're talking like an above ground pool, maybe an 18 to 24 foot pool, you consider just not the raw materials, but maybe having like a pool company help set it up. You're looking probably like $7,500 to have that installed completely. So 10% of that would be $750 a year. Now, for myself in this pool, I certainly don't spend $750 a year in maintaining it. Now, one thing is I am in New England, so this is a seasonal pool. It's probably only open 4 months of the year. So my chemical costs, my pool chemical costs aren't going to be nearly as high as someone who's in, say, Arizona or Texas who's got a year-round pool. But anyways, it gives you, it gives me an idea of, what the base rate is of people expecting to pay for maintenance of a pool. And if I run my calculations, for example, I've got a pretty good system of doing the manual measurements and tracking the pH and adding the chemicals, and it's nowhere near, $750 a year or even the other amounts for, $300-400 for a seasonal pool. So, if I can automate that process of, being able to check it and the chemicals and running the pool filter with electricity, I could probably cut that cost in half. And that can be sort of the value sell for this product, is that, one of it is the money part of it is that, you're going to save yourself, $250-300 in your first year of using it. And if you're going to charge that amount for this product, say I'm going to start with $299, say, for this, then you could say, well, you make your money back after the first year. So that's a good selling point to have. Of course, the other part is selling point would be the automation of it and taking away the complexity. Like, oh, well, I don't know when to add the sanitizer. I really don't know what it means when my pH is too high or too low. So obviously this system will help take that complexity out for you and just tell you what you need to do so that you have, good pool water for swimming. But, sometimes that's not enough, right? So whenever you're designing a product, as always, you really got to think of the value side, and you got to think about, the features that people want, not necessarily the features that you like. For me, is making it, I really like screens. I like being able to see the pH, like being able to graph it, and I'm kind of I could be a data geek and follow that along. But, in terms of like the end consumer, they might not really, well, they're probably not going to care about that. They just want to know, is the pool running fine? Do they need to do anything to it? And that, hopefully it's saving them money. So that's kind of where I went with my business plan. Again, you can look at that on my website, and hopefully that'll be helpful for other people as just a rough draft baseline. So the other thing I've been looking at, now this is going to the technical side, is looking at the Wi-Fi connectivity. So right now I've got an Ethernet shield. So this is basically just a Wi-Fi module that's got all the pin connections you can plug into your Arduino. So I have that working, so I can read back the data from the system, the pH or the water temperature, and put it up on a website that I can view on my phone or here on my local network. But that's not really an end consumer product level. Really what you need is this to be hosted on something like Amazon Web Services or Google Cloud or Azure from Microsoft. There's a lot of back end stuff you have to do. It's got to, send the data maybe through JSON or some sort of format. You got to have user logins and stuff. So that's, especially for this project, it's nothing I really want to get into, even though it would be interesting to see how some of these cloud services are really trying to serve Internet of Things devices. I've done these types of things for purely software, not for hardware device. So what I decided is I would look at some of these different, I'll call them cloud service providers, whether that's the right terminology, depending on how you view it, but the one that I decided to go with is a company called Electric Imp. Basically what they do is they provide you with, a Wi-Fi module that has the software hooks in it to do a secure Wi-Fi connection through your network to the cloud. For example, be hosted on Amazon Web Services. But they provide a lot of the front end and the maintenance for you, right? So that you can set up the dashboards for your users and things like that. Now, of course, you have to pay a monthly/yearly fee per user, but the developer accounts are free, based on, limited usage. I don't know how many, polls or interactions you get a day. And an electric imp isn't the only one. There's another one, particle. That one looked pretty interesting, but I think I'm going to go with the electric imp. I've seen those guys for a while. I wanted to try them for a project, so I think this would be uh, the perfect project to try it for. So I'll take a look at those guys. Their hardware, the Wi-Fi module is even cheaper than some of the Ethernet shields. And so we'll try that, and I'll see how it goes, and I'll do some future video updates on that and how that rolls up into this, and we'll see how that works out. So that's kind of what I was looking at this week, and for this next week, what I want to do is I want to first thing is I want to finish up hooking up all the sensors that I got. So I got a UV sensor. I've also got a turbidity sensor that essentially you can use to measure the clarity of your water. So that could be another thing that could go in my water balance equations, I'm going to call it. And then I am going to use my current Ethernet shield just so I can start collecting data. And actually the Ethernet shield I have has an SD card on it. So what I can do is start saving the data at SD. So I'm just going to essentially use it as a simple data logger, try to run it for 24 hours so I can see how the pH looks versus the temperature, versus the chlorine levels. First make sure that the system can run continuously. Make sure the data makes sense. Then I could start plotting the data and seeing that okay, this the data is going to work the way I want it to before I try and start putting it up into the cloud with Electric Imp service. So that's what I have for an update for this week, and we'll see how much I get done this next week. And I'll see you guys for the next update. Thanks.